Good morning, everybody. Wow, you're a really polite cloud. So usually when you say good morning, everybody in the cloud is kind of asleep. So that's great, guys. That's amazing. So today I'll talk about a journey about becoming a cloud native and like how to move to the cloud in 3 steps. Why 3 steps? So some background. Actually, there's usually a photo of me, but as you can see me, you know what I look like. I don't know where it went. Now we also have images. Obviously, you can see me. I'm working as a chief technical strategist for a company that's called Dynamically. We build monitoring solution, performance management solutions, and as part of this work, over the last year, we spent a lot of work with our existing and new customers that have something like a cloud project going on. And what this actually means, what a cloud project is kind of different to whoever you talk in the organization, where organizations are. And the 3 steps is kind of what came out of this experience that we had over the last year and a half or so. Yeah, and I really never smile on photos, so you have to see me live to see me smiling. So overall, I'd say when people talk about whether it's containerization, microservices moving to the cloud, we see 2 different variants of what they're actually doing. Some call it Bimodal IT, if you want to hear a buzzword. I just see it like the 2 cooks in here. Like the one here on the left-hand side, what he's doing, he's taking something existing and just repackaging it into smaller containers. Yeah, you see the flow here? To make it easier to deliver, easier to ship, and easier to distribute. So it's more or less using existing applications, but applying new paradigms to these existing applications. And there's also these projects where people are really rebuilding their entire platform or building new platforms. From a distribution perspective, we see more people being on this side here than being on this other side that they're rebuilding the platform. So there's not that many companies out there that just say, okay, guys, stop everything for the next 2 years. We are building a new platform, and then we come back to work on new requirements. And also the whole idea of being able to ship smaller units, being more agile on this one is a prerequisite for the other one anyway. So while not everything might be super cloud native, there is some cloud native thinking in a lot of projects in there. And obviously the differences that you see and that you might have also experienced moving there, where we have like this paradigm shift talking about developers, we are obviously moving away from these big monolithic applications to like more purpose-built services, the whole idea around microservices, smaller units that have a specific purpose. Again, this doesn't mean that necessarily we take apart our entire application and make everything microservice and by microservice architecture. From my experience, it's not what we're really seeing. So people usually take certain pieces out of their application, most likely those that they're having most issues with, and then gradually migrating to microservices rather than tearing everything apart instantly. But again, the idea is you have these smaller teams, smaller release cycles, and I guess you guys are aware of like all the advantages why you're trying to touch microservices. I think you're also aware of the idea of the 2 pizza box team that was coined by Jeff Bezos as Amazon. So there shouldn't be a team bigger than that it can be fed with 2 pizzas, being able to deploy a feature in production. And I think that for me is a very crucial idea if you come from a more traditional background from monolithic applications. When you ask people, okay, how many people do you need to push something into production? And they might tell you, yeah, I can do it. Okay, so what do you do? Yes, I have to talk to this guy to get this, and I have to talk to this guy to get this done, and so forth. So the idea of really having these teams being able to push into production is, I think, something very powerful. The other side of the coin is, that sounds great. Okay, now we're part of this development team. We can push stuff into production. That's great. So we don't have to go through all of these processes, talk to ops guys forever, like in the Jeff Bezos case. But then the CTO of the company might get back to you and say, yeah, but you know we have a deal here. If you build it, you now also run it. So suddenly you're getting operational responsibility for that code. And oh, wait, so I'm not just shipping this to production, so I have to keep it up and running. I have to ensure performance. I have to test this stuff in staging and load testing and everything. Yeah, what do you think is going to happen? So it's a 2-sided coin there, but I think it's still a great movement that enables a lot. And I think a main reason why we were actually able to have like microservice and it's more self-contained smaller units that individual teams can ship to production, because shipping per se has become much easier. I remember back when I started in software development in the old JEE world, and you read the JEE specification, there was a role in there that was called deployer. So these guys like were totally sure that there's somebody out there who sees it as the destiny of his life to deploy applications. I mean, that's not where we want to be right now. But having containers available, we really have these standardized building blocks. And the great value we get out of these standardized building blocks is, I don't need to know what's running in there. I don't need to know whether it's Java, it's Node.js, it's a MongoDB, it's some type of GraphDB, or some stuff I've never heard of. I know that if I know the image name, I know how to start it up. If I know the endpoints, I can actually work with it. So we really move away from these big bang releases and special build applications to continuous delivery. And obviously compute has also completely changed. So again, like years back, if you wanted to SSH into a machine, you actually knew what the name of that machine was. And I remember talking to people, and like they really associated like the names they had for the naming scheme with specific machines that were running specific applications. So if you log into EBC AYZ 215, that's the machine that's running the database. Because we had these hardwired data centers, now it's platforms like Cloud Foundry totally goes away. We just go to the console and type in, we need 4 instances of a service. And to be totally fair, we don't really know where they're started. We know they're started somewhere, but we couldn't tell the machine. Obviously, we could figure it out. And also, to a great extent, we don't care. So a lot of these whole deployment processes have become much easier. And we can gain a lot of agility in there. And that's pretty much how I just wanted to kind of lay the ground that we're talking about the same thing. So eventually, we're adopting certain pieces of this along the way. And we just say that it's not an either or. So it's not black and white. So you're cloud native or you're not cloud native. We really see this as a journey that a lot of people go through, and like 3 stages how people kind of embrace this approach. The first one is really continuous delivery, or then eventually also continuous deployment here, which is kind of like the groundwork for a lot of stuff that has to be done. If you remember back in the Agile days when you wanted to have a CI environment, being able to actually run code in a CI environment was a big deal. And we now move to that stage where we really want to have like this continuous delivery, continuous deployment pipelines set up. But most of what people are doing at this stage is lift and shift. So they take their existing application and they're just massively streamlining their delivery pipeline by putting them into containers, by standardizing the way they're delivered, by building them in a way like following like the 12 factory application principles, that they're more easily to deploy, not as we saw in this image before, where there's something like a run book on how to even deploy an application. And yeah, the applications stay the same, but the really big benefit out of this, if you don't even go any further than that, you're massively gaining release speed. Because usually what keeps you back from releasing often is the process of actually releasing the software if you have to do it manually. If it more or less is at the click of a button, that's great. So that's also why a lot of the promise of moving to PaaS platforms like Cloud Foundry and so is bringing you immediate benefit, even if you're not going towards microservices, if you're not massively changing your architecture. Just having a continuous delivery platform that makes deployment to production something you simply don't have to care about anymore. Just say, platform, please deploy for me now, is great and helps you to increase speed. Obviously, then really allowing you, when you have faster iterations in development, to push this code out into production. Yeah. Throughout this talk, I'll have like 3 things as a key takeaway for you. And this is now more coming from my performance background. Obviously, when you do this, you want to ensure that your application is fast and performing well. And I've kind of developed like my 3 rules of how to write fast cloud-native applications easily. Rule number 1 is pretty straightforward. Don't write Don't write slow code. I think we're all on board with this. So, okay, what do I mean by don't write slow code? When you go through this process and you're developing much faster, we still have to check the quality of that code. And we had a program internally that we called Share Your Pure Path, where hundreds of people were sending us their replication, traces of their replication code that had performance issues, and we were looking at that code and figuring out what the actual problem was. So what more or less did, we did like this, you could call like a big down to code level survey of why applications are slow and what kind of we found as common patterns in that code, why it wasn't working well. So along this continuous delivery process, besides checking the functional quality of your code, you also have to check performance related metrics. And these are the top ones that we came out with. The first one is n+1 interaction patterns. What's an n+1 interaction patterns? It's like an n+1 query if you're using an OR mapper, so you're just executing the same statement over and over. You're doing web service calls multiple times. Now you might say, this is a pretty stupid idea. Why would I ever do this in my code? Thing is, you easily use somebody else's OR mapping layer. And the configuration is just not right on how the data is fetched. So you run into this n+1 query problem. Yes, it can be easily solved, but it's still something we see constantly or very often coming up. Somebody also might repurpose your OR layer, use it differently, and suddenly there's an n+1 query pattern in there that you didn't think of before. We've also seen this, especially when people start to take applications apart, because what used to be a number of method calls are now remote service calls suddenly. And it just kept the control flow as it used to be before, just moved it into a service. But again, what used to be some in-memory method invocations are now remote calls over the network. So this is just something to really be aware of and take care of. And depending on how you structure your code, it might not be that obvious for everybody that the way they're using the code is actually causing this effect. Yeah, duplicate interactions. Once you start looking at code, sometimes and you have independent teams working on independent units, they might do the same thing. Checking credentials, validating users are like classical examples. What's happening there? So you have different pieces of the code that actually do the same thing, not passing things on, but they're doing it over and over and over again. This is also important from an architectural perspective because in many cases this is really a validation of the bounded context principle which we want to build into these microservice teams. Because if everybody in your team or many are dependent on one thing, there is like an interconnection that you might not want to have in there. And secondly, these services that are then called multiple times over and over are very often single points of failures. Another example is authentication services that are called. So everybody's calling them, everybody's relying on them being available to process a single transaction. And if they fail somewhere throughout that execution chain, the whole code's no longer working. Yeah, more than 10 service hubs. Microservices are great, but we've seen that once code reaches a certain complexity from a distribution perspective, it gets really hard to debug and manage. And obviously the 10 are kind of like a rule of thumb, but if you're building an application that's using multiple services, once it goes beyond 10, we see the number of problems in the code and the complexity to debug and find errors significantly increase. So of all of these applications that we looked at, those that really had significant problems, many of them had too many service hubs in there. Highly asynchronous applications, they're just hard to understand. I mean, it's great to write asynchronous code because it performs better, you can do more stuff in parallel. But it's just a good word of warning to tell you like 90% of your code is running asynchronously. So if you ever try to debug logical errors in there, that's getting super tricky. Doesn't mean that you have to do everything synchronously. It's just an indication that it's really hard to understand. So, and we've seen examples where there's like 20 or 30 asynchronous streams in a code. And also from a performance and optimization perspective, it gets really hard because there's no more visible consistent behavior in how the individual services are actually replying. And the last one is unusual log activities. So Who of you guys is actually looking at the log output of your continuous integration environment? Not that many. How much log output should there be in your continuous integration environment? So, my personal opinion, close to zero. Because if there's a lot of log output in there, the question is, why is it there? It should behave like mostly in a standard fashion unless you're testing error cases. And if you're kind of filling up your logs in a default situation, what do you think is going to happen when there's actually something really going on? And believe it or not, we still see people, especially people putting a lot of log statements in during development, and it doesn't really matter, let's just put it on info and log it out there. It's not really error or debug level. And logs can then also slow down your code, and there's just lots and lots of log activities going on. If there's an error in one of the test cases that actually passed as a log output, that should also make me suspicious, because why did this test pass if there's actually an error in my log statements? So what we did, we kind of took this all together, because that's like a lot of dimensions. I've shared some of them, so in total it's about 50 or so of them. And we built what we call the continuous performance scorecard. So that spider diagram that you see on top. So what it more or less does, it takes any type of transaction, looks at it end to end, what you're working at, and says how is it behaving from a response time perspective? How is asynchronicity? How's threading doing? How are we doing on database calls? How are we doing at complexity? And then gives me actual hints on how to resolve these issues. So why did we build this? Because you could also do it manually. Like if we give you all the rules, you could do it manually. Yes, you could. But keep in mind that as we want to increase our release speed, the whole process of checking our code for quality has to get faster as well. So there's no big value in there if we can ship a code theoretically from GitHub to production in 10 minutes, if the whole validation process of this code takes us 2 to 3 hours. So we're again losing speed in there. And what you would then see along continuous delivery pipelines, that there's some spot in there which is mostly in the staging, moving close to production side, where like everything suddenly backs up and all of this is in there. So the idea is, if you want to automate these pieces, also automate looking at your code and validating it against these constraints. Doesn't mean necessarily that everything that you see in there, that everything we would tell you is like an issue that you couldn't ship into production, but you should be at least aware of it. If there used to be 3 database statements in a transaction and now there are 50, this is something as an architect you might be interested in and question the development, or ask the development team, so why is it going on like this? And yeah, just to mention here, because this is a product, there is we're also offering a personal license that you can use for your own purposes for free as well, obviously. So this is really what's happening in stage 1. To recap, if you want to move faster, you also have to make your processes that enable you to check the quality of your code move faster as well. Because otherwise, you're just moving bad code faster into production, and that's not what we all want. And it also gets harder, and we also don't want to increase the effort for shipping code. Because what's the value of automation? If you say, okay, before we had like 1 or 2 people looking at it, now we need 10 or 15 people looking at it. Doesn't make a lot of sense either. So stage 2, so once people have kind of figured out their continuous delivery, continuous deployment pipeline, depending on how far they want to go, so whether they really want to push something to production automatically, I say, okay, we have mastered this, but there's this one component. And what we realize, whenever stuff breaks around continuous deployment, it's always this one component. And whenever we touch it, we break other stuff. And we had situations where 80% of all deployments simply failed. Because it was this one component, and it was always hard to touch. So then the idea is, this is like the first piece that you take out of this like big monolithic architecture and build your first microservice, because you have to touch it anyways right now. So it's a good starting candidate. And had a really good conversation with one of our customers, Prep Sportswear, and the outcome was more or less, when you move to microservices, many people think defining a first service is hard. It's actually not. First, you pick the pieces that are on fire and that really need fixes. Picking your second, your third, and so it gets much harder. because then you're also starting to touch pieces that are not working that bad anymore. So it's really the first microservice that you're starting to build. And suddenly scheduling and orchestration comes into the game as well. So far, well, you technically used a scheduling and orchestration platform underneath, but it was just like this one big monolithic block that you were scheduling, so there was not like a lot of scheduling magic going on. But now as you move to microservices, in many cases, it's one component that's not performing as well. You want to dynamically scale the amount of instances. You might want to have it for A/B testing and so forth. So scaling framework suddenly really starts to play a significant role in this overall process beyond just being a means to ship code to a certain environment. What we also see is that architectures become polyglot at that point. Polyglot meaning people then say, okay, so we're not part of like this big entire monolith anymore. I know we agreed we're using Java and we're using Oracle as a database, but we're building this API layer that does recommendations. So I'd like to use Node.js in a graph database. So why should I use something that doesn't fit? I also don't use a fork to eat my soup. So why should I be doing it? And then people, some are resistant, but then they say you don't have to worry, because remember back then we have standardized building blocks. You use an operations guy, don't need to care. You get like this piece of, it is one container, you run it, you have to care what's inside. You might not even know. And we've seen this in some cases be taken to an extreme, where I was talking to the CTO of a company and asking him, so which technologies are you using right now? And yeah, there's some Mongo, there's some Java, some Go, some Node. I think we also, maybe we're not using Mongo anymore, and I think the guys are using something different right now. And I was just asking him, so what you're telling me is you as the CTO of the company don't know which technologies you're using anymore. And yeah, I think you kind of have a point there. Doesn't this somehow scare you? Yeah, now that you're mentioning it. So I think overall the story is there. We're gaining more flexibility, and we're getting this flexibility, and it makes a lot of sense to not use technologies for what they're not built for. And it also makes our life as developers much more fun. So you don't have to use a technology for something that is really not used for. We just have to become aware that our entire environment becomes more complicated, and the skills to debug and manage these environments are kind of leveling up as well. It's easy to only manage a Java and Oracle environment. If you have 10, 15 technologies, it becomes way more complex. And the last one is something that people in the beginning think it's great, and usually after a couple of months think, wait a minute, that's actually tricky right now. Independent release cycles. Now you have that big block that's still left, and you have the microservice and say, that's great, we can release the microservices at this release cycle, we release the other stuff at that release cycle, so everybody can start releasing it whichever release cycle fits them best. So that's great, we have all this flexibility, we're not dependent on each other anymore. And at some point you then talk to the DevOps or the operations team, say, so it would still be great to know what's running in production right now, and who did what, because guess what, we are just handling a production issue, or we're kind of trying to optimize something for our overall infrastructure, and while we were doing this analysis, you guys were deploying new code. That doesn't make our life much easier. So the whole communication flow has to significantly improve in the company with these guys, because otherwise you kind of like get a more or less chaotic systems where everything keeps changing and you have no idea why somehow. So what we learn in this stage is, again, to my 3 rules of writing performant cloud-native applications. Rule 1 was, don't write slow code. Rule 2 is, don't write code that doesn't scale. Again, pretty simple. So what do we see here? Once we move to microservices, what we're essentially doing with the smaller building blocks, we are replacing a local method call with a remote call in many extents. And we put a lot of infrastructure in between that makes this execution suddenly possible. What we learned as like the key metrics, if your service call payload is beyond 500 kilobyte, that's actually bad. And 500 kilobyte is a lot. So what we recommend people looking at from an environment complexity perspective, if you're using more than 500 kilobyte, that's a really, really big service call. your overall architecture shouldn't, an overall transaction, like your booking transaction, whatever, shouldn't use more than 50 service calls as a whole. 50 is already a lot, but that's kind of like borderline where that we defined. You obviously might want to go for less, because the more interactions you add, the bigger the likelihood is, if something breaks, that it affects your overall application. And if you have like really inter-tier heavy interactions, like many tiers talking to each other, you really have to reconsider granularity of your services maybe. Because if every more or less slight request is remote, you also might think of, okay, what do I have to simply put close together, because it just makes more sense. There's 10 interactions between these two services for a transaction. So why are they actually on two entirely different machines there? And the last one, status codes. Only OK has to return 200, period. This is something, I mean, that's like basic HTTP status codes. If a service fails, it's not returning 200. You're making your operations guy's life really hard. You might say, yeah, that's absolutely logical. It returns 500. Trust me, we get regular requests whether we could not reconfigure monitoring in the way that even as it is returning 200, like there's this one field in this reply, and if this one field is in this reply, it actually means that this transaction failed. Also, it's returning 200. And usually when you then tell the guys, yeah, that it shouldn't return 200, that's not how the protocol is supposed to work. You still see it very often. I just bring this up because it's really near and dear to my heart, because it makes the system really hard to debug and understand if you're not following conventions. So if you have people in your company who want to convince you, yes, even if it's wrong, we still return 200 because we can return to something. No. There are so many status codes. That's the reason why. And the key here is really then, once you move to those microservices, is getting kind of like a visual representation of what this microservice environment looks like, which for me very often is key. And this, in this case, is a e-commerce production system. And you see that also the services are monitored, where we have the product info query and how it goes across all the different layers, where it's checking somewhere here, whether it's a promoted service, what the ratings of these services are, and so forth. And you even see that in the service interactions, as I mentioned before, independent release cycles, version 1 of the product service is calling version 1 of the API rating service. And actually, these two services would again be another version of the same service. So just understanding which versions of which services are actually calling what in production is super helpful, especially if you want to find problems in there. And my recommendation to you is figure out how to get this information before you put stuff into production. Because when it breaks and you then start thinking of how to figure out, okay, how do I even know what's going on here, that's a bit late in the game. And now coming to stage 3. So stage 3 is more or less the top level if you want to move to like the cloud native applications, where we usually don't see people say, yeah, now we have now first microservices running, we got like the release cycles working for us and everything. But now we really want to scale up and down dynamically. We have 3 services running, we only need 2, and we don't want it. And now we're also adding some more advanced resilience in there, like caching mechanisms and so forth, if parts of our infrastructure breaks. And now we're getting brave, we're deploying across clouds and so forth. And at that point, we don't really care about the infrastructure anymore. And here we come now to rule number 3, understand application behavior. And there's actually 3 ways on how you can understand application behaviors from a monitoring perspective. Number 1 is health monitoring. So that's the basic monitoring that you get, and many people stop there. Health monitoring is only there to tell you about symptoms. Services getting slow, machines getting saturated. It's not helping you to solve any problem. It's not even helping you to understand those problems. It's just giving you raw data. Orchestration monitoring, which helps you to understand the causality of your interactions. So who's talking to who and how like these health failures are actually related to each other. And eventually application monitoring, what's my code doing? Why is my code reacting in the way that it's doing? So many people stop at level 1. Okay, we know that systems healthy or not. Okay, good to go. That's definitely not enough. And this is an example of what such an environment looks like. This is roughly 3,500 services that are running in here. Some of them are failing, which, by the way, is not a big deal because no of our application is really impacted. What do we want to show you with this picture? Yes, it looks like a Death Star, and yes, it's complex. So you better figure out how to solve problems in these environments before you run in there. And again, keep in mind your environment's not static. In the morning, you might run 2 instances. During lunchtime, you run 7 with a fail over here. And later at night, you run, again, less of those instances. So everything's more dynamic and harder to manage. My recommendation is really, and obviously I'm a bit biased here, don't fly by hand here, which more or less means if you want to manage these environments, you need some tooling that helps you to realize this. This is an example of a microservice environment that had a problem. You see up there, it's about 820 billion environment dependencies that were analyzed. That's not wrong. It's really 820 billion dependencies. The reason was a networking issue on with some of the Docker containers, and that's what the dependency graph looks like. Interestingly, it really looks like a mushroom cloud. The reason, a couple of machines, many containers, services, talking to other services, eventually being used by a couple of applications. And don't forget about network monitoring. Please, guys, don't forget about network monitoring. I know we didn't care about network monitoring for a while because it used to work pretty great. Now we're building way more distributed applications. Please have a look at them. Again, if you want to make it part of your environment, if you go to your PCF environment, there are these nice service broker tiles where you can give us a try. You can also stop by over here, obviously ask me questions. We are unfortunately a bit over time right here. If you still want to ask me something, feel free to step up or catch me around here. So that's it from me. I hope you enjoyed the talk. Enjoy the rest of the conference.